The first step in solving the problem number 3 is use a tree diagram depiction of the probabilities Kf of receiving false positive and false negative to access and identify the given problem for the sample diagram. 1, 2, 3, go. So guys, upon checking this problem, the first step in solving this problem number 3 is use the tree diagram depiction of the probabilities Kf of receiving false positives and false negatives to access and identify the given problem for the sample diagram. Okay, let's assume that this A is there a difference between having COVID-19 and not having it in the given sample B, C, and D. When indicating the positive and negative outcomes of different tests, where the positive values are 0.05, 0.10, 0.15, and the negative values are 0.01, 0.02, 0.03, and so on. So, wherein 10% of samples arriving will contain COVID-19 viruses, which leaves us 90% of probability that the same do not certain or contain a virus. Under 90%, there is 0.05 probability the false positive for B positive. Under 90%, there is 0.05 probability of the false positive for B plus, 0.10 for C plus, and 0.15 for D plus test. And lastly, 10% of the sample contain presence of COVID-19 viruses. There is 0.01 probability of getting false negative for test B minus, 0.02 for the test C minus, and 0.03 for the test D minus. And for letter E, we arrive to continuously by simplifying and multiplying the values of P plus, C plus, and D plus under B minus, which is 90% of the sample does not have the presence of COVID-19 viruses, which equivalent to 0.000075. And in letter F, we get all the values B plus, we add and multiply the values of all the positive and negative probabilities and able to get the probability tested sample, which is 0.5891 that contains COVID-19 viruses. In question A, find the probability that the laboratory will falsely assume that the absence of COVID-19 virus in the sample. I, the laboratory is false assume the presence of COVID-19. And the solution of this question is I times B plus C plus D plus times the A minus. So upon expanding this solution, it will come I times B plus times A minus times I times C times O plus A minus times I times D times B plus C plus and A plus. So guys, upon getting this, the answer of this question is 0.15 times 0.10 times 0.15. So the final answer of this question is 0.000075. So next question is B. Find the probability of sample tested by the laboratory is reported to contain COVID-19 viruses. I, the laboratory will falsely assume that the absence of COVID-19. So the solution in this problem is I times the B minus times A plus I times B plus C minus times A plus I times B plus C plus D minus times A plus. Upon expanding this solution, it will come I times B minus times A plus I times B plus times A plus times I times C minus times B minus B positive plus I B positive times A positive I times C plus times B plus A plus times I times D minus times E plus F plus G positive. Upon solving this problem, it will come in situation of 0.1 times 0.99 times 0.02 plus 0.99 times 0.98 times 0.8, and the final answer is 0.5891. So next is letter C. What percent of the samples tested by the laboratory are reported to contain no trace of COVID-19 viruses? And again, I is the laboratory will falsely reported by presence of COVID-19 in a sample. Solution in this problem is I times B positive, C positive, D positive. So upon expanding this, it will come by B positive, C positive, D positive times A positive times I times A positive plus I times B plus C positive D positive times I D plus B plus C plus and A negative. I times the D positive, B positive, C positive times A positive plus I times A negative times I times E positive times A positive times I times C positive times B positive times A negative times I times D positive times B positive, C positive, and A negative. Upon substituting 0.10 times 0.9910.98 times 0.97 plus 0.90 times 0.5 times 0.10 times 0.15. On getting the final answer of what percent of the sample tested by the laboratory are reported to contain trace of COVID-19 virus, we'll multiply it by 100%. So the outcome and the final answer is 9.5%. So lastly, D. What percent of the samples tested by the laboratory will report the absence of COVID-19 virus is unsampled? Again, I is the laboratory will falsely reported the absence of COVID-19 in sample. The solution in this problem is I times B negative U B positive C negative U B positive C positive B negative. So upon expanding it again, we will come in I times A positive times I times B negative U E positive F negative U B positive C positive D negative times A positive plus I A negative B minus or negative U B positive C positive D negative times A negative. Substitution 0.10 times 0.01 plus 0.99 times 0.2 plus 0.99 times 98 divided by 0.03 plus 0.90 times 0.95 plus 0.05 0.90 plus 0.05 times 0.10 times 0.85. So again, in getting the percent of samples tested by the laboratory, you will multiply it by 100%. So the final answer is 90.5%.